Hi all, very good evening. Welcome back to the Java classes again. So this is the next topic which we are going to learn in this class, that is packages. So it's very important topic. So this topic consists of four phases. The first phase you can clearly see in the picture, its definition and purpose. So in this phase, we will discover the concept and purpose of packages in Java and how they help to organize the code. Second phase is naming conventions. In this, we explore the best practices for naming packages in Java to ensure clarity and consistency. Third phase is how to create a package, how to use a package, how to import a package. These things we'll learn in this third phase. And fourth phase, we are going to just see the real-time examples and how these packages can be used to enhance the code and reusability. Clear? So to start with, I'm going to work with the definition of a package. So package is defined as collection of class files and subpackages. So what is the advantage provided by this package? The advantage provided by this package is that it avoids the collision between the class files. Here, what is meant by collision? Collision of class files explains regarding overwriting of class file. So overwriting in the sense, when I create a class called add, so for this add, a class file will be generated. In the same way, if I create one more class called add, right, for this also class will be created, but this class gets overridden by this, this class gets overridden by this class. So what all the contents are there in add class, that will be overridden by this class. So which means indirectly there is a collision between these class files. So to avoid that collision between class files, we have been given with the concept of package. So what actually the packages do? So these packages works with the following procedures. First, very important, creation of package. In this phase, you're going to learn how to create a package. Once the package is created, the next phase is how to compile the program where the package is enclosed, right? So that is your second one. Third one, how you're going to import a package. And last but not least is setting of class path. So when package concept is used, different users can have common class names in their programs, transferring them to their created respective package. What is the meaning of this? Suppose I have add.class file and one of my colleague, even you want to create add.class file in the same system. So there are two add.class files. What happens is there will be a collision between these two class files. So instead of colliding, what can I do is I can create a package. I can create my package by name CMC, let us suppose. So in this package, I can create my add.class file. So this add.class file is restricted to my package. One more person is going to create a package called ATC, right? So in this, he is going to create one more class name of his own, that is add.class file, and is going to implement his own code. Here I'm going to implement my code. So this code is different and this code is different, which cannot be overridden or which cannot be collided, because this add.class file is restricted to this package and this add.class file is restricted to ATC package. So packages are different, so .class files also be treated as different. Is that point clear? Now, the first phase is how we are going to create a package. Name itself suggests we are going to use a keyword called package. It's supposed to create sub packages as well. It should be enclosed as first instruction of a program. This is very important. Whose .class files is to be transferred to a specified package. See, we have the syntax for that. I'm going to create my package by name with the keyword called package, where package name, I'm going to take CMC, okay, or I can take one more package name 2, I can take one more package name 3, so on. I can take a number of packages, and that is not mandatory, right? I can stop with only one package also. More than one package can be specified in a simple program as the syntax suggests, right? So how I'm going to import this? So this we are going to learn at the point of import, okay? Just I'm writing here. If I want to import a single class, how I'm going to import. So this is the syntax I'm going to use. Import package. What is the package name I've created? Followed by which class I want to import. Okay, in the same way, if I want to import a complete package, I'm going to use import package. What is the package name? Dot star. So whole package will be imported. Okay, that I'll say with you with an example so that you'll understand. First phase is creating a package. So you need to keep in your mind that package is created with the keyword called package. So I can create like this package CMC. Okay, with program I'll say you. Next phase is compiling a program where package is enclosed. So a Java program where package is enclosed gets compiled with a command called Java-Cse. As we do for a normal program as well, it is going to compile with a command called Java-Cse followed by -d, that is directory. D stands for directory and should be specified by the path where the package is created. Suppose Java-Cse -d. If this -d, this path stands for directory. In which directory my class is. Is that point clear? Or it's which directory my package is. Then afterwards, this is my class name dot Java. If you specify like -d and that path, okay, automatically you can work with your file. So this is how you're going to compile your package or program which is enclosed in a package. So that is your second phase. Clear? And third one is how we are going to import a package. As I said, the keyword called import is used to import predefined and user-defined packages. So there are some predefined packages, okay, and there are some user-defined packages you can create by your own. See, in this previous slide, I've created package CMC. This is my user-defined package name. Is that point clear? But there are some packages like import java.io.star. Is that point clear? So this is a package you're going to import. Okay. So this is predefined package, which is defined by the system itself, by the language itself. But here package CMC, ATC, my name Kishore, right? All these I can create by user defined packages. But there are predefined packages as well that we'll see in coming class, right? Now, import. You're going to use an import. So import can import a complete package or it can import only a class file. It's supposed to import sub packages under main package as well. So this is how we are going to import package name dot star. So if I have a class called add, so if I want to import, okay, I have one class called add and I have one more class called sub. Is that point clear? So I can import some CMC dot star if I say, because here I'm going to write here package CMC like this. Here also I'm going to write here package CMC, right? So if I write like this, what happens is this add class is created in CMC package. In the same way, this sub class is created in CMC package. Now CMC package consists of two classes. This is CMC package. It consists of add. It consists of sub. Is that point clear? Now, what I can do is, if I say import CMC dot star, what happens is whatever the classes present in this CMC, all these will be imported with this syntax. But if I say only directly like import CMC dot, I'm going to say add. So this means that only one class from the CMC will be imported. Is that point clear? So this is how I have written. So import package name two, or this is one. You can take a number of packages, right? Or you can take dot star, or you can take class name. So see, import package name dot star or import package name dot your class name. This is how I have declared. Is that point clear? That's what I have shown you. You can see here. You can import a single class like this. Import your package name dot class. Or if you want to import the complete package, you can say directly import package name dot star. Okay. So all the dot class files present in that package name will be imported with this second syntax. Is that point clear? Now, last one is setting of class path. How we're going to set the class path? You're going to use an environment variable, class path, which is used to specify the path for the packages and dot class files are enclosed in different directories. Is that point clear? So if that is enclosed in different directories, classes, then you're going to use this setting of class path. The environment variable should be used with a command called set. So you're going to use this set. So C colon set, your class path, followed by in which drive it is, followed by in which directory it is. Is that point clear? With example, I'll show you, but keep these all in your mind. Okay. Now there are some points to be remembered to work with these packages. So what are those points? When program name is specified for such a class where main method does not exist, that class should be attached with public access specifier. So generally I'll take class like this, class, suppose some sample. Okay. So in this, I'm not going to use main function. Just I'm going to use one method and I'm going to close it. Let us suppose here main method is not there. So if main method is not there, generally we leave in the following way, class sample. But if I use this package, in this package, especially in a class where there is no main method, if in a class there is no main method, right? So that class should be declared with public class sample. That is not there in terms of normal class, right? Inheritance or whatever it is. But in terms of packages, it is mandatory. If the main method does not exist in that class should be turned to your public. Maximum of one public class is must. A program can be enclosed with any number of classes with no access specifier specified. So you can use default. Okay. In terms of your package, by default, those classes are treated as private classes. If you're not going to specify, okay, with no access specifier, generally it is public to package. But here, in terms of your packages, if you don't declare, by default, those classes are treated as private. Okay. If a package is enclosed with a sub package, import will import only the main package. Is that point clear? There is a package and there is a sub package. So when you use this sub package which is enclosed in your main package, right? Then if you say import, that will import only the main package, but it's not going to import the sub package, right? To import sub packages, a separate import statement should be enclosed in a program. Okay, how I'll say you with an example. A class which is attached with public access specifier, the properties of it can be accessed in the same package and outside the package as well. That is same in terms of your package, right? Public that can be accessed inside as well as that can be accessed outside the package. Okay, next. This is an example illustrating the concept of your packages. Very important. Please students just see here. We have C colon. This is a C drive. Okay, command prompt. In that, I have a directory called student. Very important. I have I have a directory called student. In that, I'm going to take edit test.java. So when I say edit test.java, a window will be created which is called as editor, where I can write my Java program. Okay, so in this test, so now this is test. In this test, I have created my package called CMC with the package name. So in this package, just you can see here, this is the class I have declared. In this class, there is no main method, right? We have only one method, but there is no main method. So as in this test class, there is no main method. This test class should be converted to public. This is important. Okay. So in this test class, what I'm going to do now, so I have test and I have a package by name CMC because I have created my package name CMC. Okay, so now in this test class, I have only X method and it is printing welcome. That's it. Okay, and this test is present in student directory. Okay, and this test is class, the student is directory, CMC is package, right? So now you can see in the student directory, first of all, you can see here in the student directory, I have created test. So test is present in student directory. In this test, what I have declared, I've declared one X method and welcome I have printed. Now in the same student, I'm going to create edit sample.java. So when I say sample.java, sample will be created like this. Okay, so I'm going to write here sample. Is that point clear? So I'm going to write a method called y because sample consists of y. But what I'm doing again, I'm just taking my package name as CMC. Now in this CMC, test class is present, sample class is present, and in the sample class also there is no main method, right? So automatically this should be turned to public. So in this CMC, you can see in package CMC, you are declaring a test. So test is present in this package CMC. In the same way, in this package CMC, there is one more class called sample. So you are going to write sample, right? Now you're going to compile this test as well as sample to programs, right? So Java-C-D test.java, it will be compiled. Java-C-D sample.java, it will be compiled. Now you can see in the same directory, okay, what I'm doing is edit m.java, I'm going to say. I'm just taking as I've done here, edit test.java, as I've done edit sample.java, a separate window will be created, right? So in the same way, I'm saying edit m.java in the same student directory. So this is student directory where I'm going to create m as my class. Okay. So here you can see here there is a main method which is present. So if main method is present, there is no need of specifying it as public. Here main method is not present in test, so it should be declared with public. Here also main method is not present in sample, so it should be public. But here main method is present in m, so it should not be taken as public. Okay, now what I'm going doing, test obj1 equals to new test. I'm creating object for your test class. Okay, and I can in the same way I'm creating object for your sample class. Sample obj2 equals to new sample. So using obj1, I can call only x method because x method only is present in text class. So in this test class, I can call obj1.x. So obj2 for sample, I've created one more object, right? Obj2. So with that object, I'm going to call obj2.y. Okay. Now, what I'm doing is, what I'm doing here is, so my, this is my directory. So in this student directory, you can see here, I have test, I have sample, I have m. Okay. So what I'm doing now, I'm moving this test and sample to your temporary directory. So it is going to become like this. In temporary, I'm going to move this test as well as sample classes, right? So even though I'm going to move it into temporary, what happens is you can see here. So temporary package I have, temporary directory is there. So I'm moving this test.java and sample.java, right? It is present in student directory. These two, which are present in student directory, I'm just moving it off to test as well as sample, that is temporary directory. Okay. Even if I move this test and sample to temporary directory, right? If I compile your Java program, like in the student package, Java-Cse m.java, right? So now the important point is you have imported CMC dot star. So CMC, it is present with test class. Same CMC is present. CMC is presented sample class, right? So when I say import CMC dot star, indirectly this import is going to import what all the classes present in your CMC package. So in my CMC package, I have test and sample. Those will be right imported to this phase where main method is there. Okay. Then class M you have created public static void main string arguments, and you have created object for test. You have called obj1.x, object dot that is sample object dot y, obj2.y, right? So now Now this is the way you compile the program in same directory and to run the program in same directory. Hope this is clear for you. So there are some Java system packages and their classes. First one is package name, that is Java Lang. What this do? This language supports classes. Okay, these are classes that Java compiler itself uses, and therefore they are automatically imported. They include classes for private types, mathematical functions. Okay, then threads, then exceptions. Then you have util package, Java.language utility package. Util stands for your utility package. It includes vector, hash tables, random numbers, like that. Okay, then afterwards we have java.io. This is input output. Okay, so input output supports classes. They provide facilities for input and output of data. Clear? And afterwards you have java.net. So in terms of your network communication supporting classes, okay, with local computers as well as internet servers. Okay, next one is Java AWT. Name itself suggests abstract window toolkits. Okay, so abstract window toolkit. So the set of classes for implementing graphical user interface. So this is abstract window toolkit. Okay, now you can see they include classes for windows, buttons, list, menus, and so on. Okay, that we'll see when we start with our AWT. Okay, next Java applet, classes for creating and implementing applets. Okay, so Java applet is nothing but it is the package which consists of classes for creating and implementing the applets. Okay, then afterwards we have a concept called very important accessing procedures provided to different access specifiers of a class. In the sense, you have public, you have protected, you have friendly, you have private. Okay, so these are four types of your access specifiers we have. So when you take these packages with the concept of inheritance, there is a concept of same class. If both packages are present in same class, what is its nature with public, with protected, with friendly, with private? Okay, that is default. Default is again either public or private. So in Java, sorry, in terms of this point, you are going to take it as private. Okay. Now, subclass in same package. So what is meant by this subclass? Inheritance, right? So subclass in same package. You have a same package in that you have created a class which is a subclass. Okay. In that, public will be accessed, protected will be accessed, default will be accessed, and private is not accessed. But whereas in same class, public, protected, right, default and private, all these are valid. So now other classes in the same package. Now package will be same, but we have other classes, right? So how we are going to react there? All these are true, but last case will be no. Here it is. Now subclass in the other package. You have a subclass and that will be in other class. Okay, other sub package. So you can see here, yes, yes, no, no. So deep public can be accessed, protected can be accessed, but remaining two, okay. Now non-class subclass in another package. So there is no subclass, but it is in another package. So it will public will be yes, they are going to see this. They have seen, then you have protected, no, then friendly or default, you can't access, and private, you can't access. Hope this is clear for you. So this is points related to your package. So here benefits of using package, you have modularity because by grouping these related classes and interfaces into package, you can easily manage and maintain your code. Encapsulation, as you know that. Okay. Then next one, code reusability, reuse of existing code. Right. So these all the things we have learned in this slide. So again, to summarize what we have learned in this. First thing, these four things we have learned. How to create a package. Package is created with a keyword called package. Okay. And compilation of program where the package is enclosed, how you're going to compile it. Then afterwards, you're going to import a package. Then finally, you're going to work with setting of class path. Is that point clear? So these all things you have learned over here. Out of this, you have just taken the concept of packages as well with an example program, right? So what you have done here, CMC, then you have test. In this CMC, test is present. Again, package CMC you're saying, again into this package, you're going to just take sample. Okay. Afterwards, this is how you're going to test that. Then afterwards, you're going to import CMC dot star. If I say CMC dot star, what all the contents present in CMC, those will be copied into this package. Is that point clear? So this is how we are going to work with the concept of packages. Hope this is clear, right? So till now we have done with our 2 units.